Hello class, today we're going to look at adding and subtracting fractions and decimals. Now, while going forward in mathematics, you probably will have access to calculators that can do this function for you very simply. And that's actually something I'm going to review the very last week of this particular class. It is still very important to know the mechanics behind adding and subtracting fractions and decimals, because it's going to carry over into other mathematical functions that you actually do, and it's also going to be very helpful when we start introducing variables into these equations to know the mechanics behind your addition and subtraction of fractions and decimals, because your calculator isn't going to be able to add those fractions and decimals once you start adding in different variables like x, y, z, and so on. So let's get these mechanics down. Let's get some practice knocked out on this. Nice little refresher here for us. I'm going to start us out really easy here with the fractions. I'm going to start us out with fractions that have the same denominator. Now, fractions that have the same denominator are really simple, because if they have the same denominator, all we have to do is add or subtract the numerator. Okay, if the denominator is the same, all we have to do is add or subtract the numerator, whatever the function tells us to do. So if we look at the first one here, it says 3 over 7 plus 2 over 7. Because they have a common denominator of 7, we literally can just add the numerators. 3 plus 2 is 5. So 3 over 7 plus 2 over 7 is just 5 over 7. Quite simple. If I look at number 2, I've got 5 over 8 plus 1 over 8. It has the same denominator, so I can just add across the numerator, and I'm good to go. 5 plus 1 is 6. We have 6 over 8. Hopefully, a bell's ringing in your mind right now that, oh, I think I'm supposed to do something else with this 6 over 8. Now, while we did the addition correct here, we can indeed reduce the fraction of 6 over 8. What can this be reduced by? It can be reduced by a factor of 2. So I'm going to divide both the 6 and the 8 by 2. So essentially you're dividing by 2 over 2, which is going to reduce it down to 3/4. Okay, anytime you can reduce, you need to reduce. Okay, we want things in simplest terms. All right, let's look at number 3. We have 2 over 6 plus 3 over 6. Now, once again, same denominator. They both have a denominator of 6, so we just have to add the numerator. 2 plus 3 is 5, so we're looking at 5/6. That can't be reduced, so we can continue on. Number 4. Number 4, we have 1/4 plus 3/4. I can just add the numerators here. That gives me 4/4. 4/4. Hopefully you can see that 4/4. Say that 5 times real quick. 4/4 is equal to just 1. 4 divided by 4 is 1. 4 over 4 is equivalent to 1. All right, let's look at number 5. Number 5, I have 5 over 6 plus 1 over 6. Should give me 6 over 6. 6/6 is equivalent to 1. All right, let's look at number 6. 3/9. Set it upside down. 3/9 plus 2/9. 3/9 plus 2/9 is 5/9. We cannot reduce 5/9, so we're done. Now, let's look at subtraction. Now, addition, subtraction, much of the same here. Properties all hold. If I have the same denominator here, then I could just subtract across the numerator to get my answer. Now, here I have 4/6 minus 2/6. Because they have the same denominator of 6, I can just subtract across the numerator here. 4 minus 2 is 2. So I'm left with 2/6. Hopefully what you're catching here is the only thing that we're doing the addition or subtraction function to is the numerator. You do not apply that function to the denominator. Okay? You keep the denominator the same, especially if they're already equivalent, and then you do the addition or the subtraction to the numerator only. Okay. Now, like I said, hopefully a little bell rang in your mind and you're like, I think we can reduce 2/6. We can, because 2 goes into both of them. So I'm going to divide both of them by 2 and reduce 2/6 to 1/3. Alright, number 8, I have 9/10 minus 3/10. I'm just going to subtract across the numerator here and get 6/10. We can definitely reduce 6/10. What goes into both 6 and 10? Well, 2 goes into both 6 and 10. So I'm going to divide both by 2, and we're left with 3/5 in our most reduced form. Number 9, I have 6/12 minus 3/12. I have the same denominator, so I can just subtract across the numerator. So 6 minus 3 is 3. I'm left with 3/12 here. 3/12 does reduce. Now what goes into both 3 and 12? It's not 2. 3 will go into both. So I'm going to divide both by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So I'm able to reduce 3/12 into 1/4. I'm going to continue on to number 10. Here I have 2/8 minus 1/8. They have the same denominator of 8, so I can just subtract across that numerator, and I'm left with 1/8. Number 11, I have 8/11 minus 2/11. 8 minus 2 is going to give me 6/11. Okay, like I said, keep the denominator, just do that addition or subtraction to the numerator. Alright, here we've got 3/4 minus 1/4. My denominator is the 4. 3 minus 1 is 2. So I've subtracted it down to 2/4. Hopefully we can see that 2/4 will reduce to 1/2, because we can take out a factor of 2 of both of those. And 1/2 is our final answer. So, addition and subtraction of fractions, fairly simple if the denominator is the same. But of course, I have to ask, what happens if the denominator is different? Alright, let's look at differing denominators and what we will do in this case. Now, in order to add and subtract fractions, we have to have a common denominator. In that first set of problems that we did, we had a common denominator in every single one. Okay, the denominators matched. That's all that means. Keep in mind, I didn't review this in the first one, maybe I should have, but the one in the top is called the numerator. The one in the bottom is called the denominator. Okay? The bottoms have to match in order to add and subtract. The bottom is called the denominator. Okay? So the bottoms have to match in order to add and subtract the numerators. That's our whole thing here. If they don't match, we have to find a way to make them match. Okay? The way we do this is we look at the numbers that are in the denominator. If they don't match, we try to figure out what we need to do to each of those respective pieces to make them match. So if I look at number 1, and number 1 says 4/3 plus 2/5 equals. They don't have the same denominator. One's got a 3 in the denominator, the other has a 5 in the denominator. What are we to do? Well, we need a common denominator. So, what we try to do is figure out what the least common multiple is. Okay, hopefully you know what the least common multiple means coming into this. If not, I'm going to give you a very, very quick and slight review. Least common multiple is the smallest number that they will both multiply to be. Okay. Now, there's a variety of ways to find the least common multiple. The simplest of which is to just basically do multiplication terms of each until you find something in common. So, if you wanted to find the least common multiple of 3 and 5, you would start out with the multiplication factors of 3 and 5. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. If I look at 5, 1 times 5 is 5. 2 times 5 is 10. And 3 times 5 is 15. Their least common multiple here is 15. Okay, that is the simplest way to find least common multiple. There are more complex ways that can be reviewed, but that's for another time. Okay, when in doubt with fractions, if you cannot figure out what the least common multiple is, you can always just multiply the two denominators to get your least common multiple. So in this case, we'd have done 3 times 5. We would have gotten the same least common multiple as 15. It doesn't always work that way, because if you look at number 2, the least common multiple for the denominator is 10. But if you'd multiplied 10 times 5, you'd get 50, which means that you would have to have done an additional reduction step at the end. But it still would have worked out. All right, so that was a slight review on LCM. Let's get this out of the way so we can actually solve the problem. So our least common multiple we found to be 15, which means that we need this denominator to be 15 on both the first term and the second term. Now, how do we do this? That is the true question. So what we need to do is if we want it to be 15, we know that we want the denominator to be 15 for both of them. We need to figure out what needs to happen to each of these terms to make it a 15. All right, what did we have to do to make 3 turn into a 15? Well, we had to multiply it by 5. If I had to multiply 3 times 5 to get 15, then I also need to multiply 4 times 5, because what I do to the bottom, I need to do to the top when converting my denominator. Okay, so 5 times 4 is 20. Then I need to go over here to my other term, my 2/5, and figure out how I made that 5 into a 15. Well, I made that 5 into a 15 by multiplying by 3, which means I also need to multiply my numerator by 3. So 2 times 3 is 6. Okay, now that I have a common denominator here of 15, I can simply add my numerator terms. 20 plus 6 is 26 over 15. And I'm done. Now, going forward, depending on the class you take, 26 over 15 may be okay to write. I would be okay with a response of 26 over 15. If you're still in a high school class or you're in another university, they might want you to convert it to 1 and, let's see, that'd be 1 and 11/15. But I'm perfectly fine with 26/15. Okay, so that's how I'm going to leave it. All right. They call that an improper fraction. They call the other one a mixed number. I prefer the improper fraction because it leaves it in a mathematical sense that's easier to work with if we continue on with an equation. Okay, so that's how I'm going to leave it for now. All right, let's look at number 2. In number 2, we have 7/10 minus 2/5. The least common multiple for these two denominators is 10. That's the smallest thing I can actually multiply to get both of them to be. If my least common multiple is 10, and I already have 10 in my denominator of my first one, I can just leave my first one alone. But in my second one, I also want its denominator to be 10. How do I do that? Well, what times 5 gives me 10? 5 times 2 gives me 10, which means I also need to multiply my numerator by 2. So I need to do 2 times 2, which is 4. Now that I have a common denominator of 10 on both of them, I can subtract the numerators, and here I have 3/10. All right, let's look at number 3. Now, in number 3, I have 5/9 plus 2/7. Now, I need a common denominator here as well. Now, the least common multiple of 9 and 7. That's kind of a tough one, right? So if I'm having a hard time and I don't want to write out all the factors, I can simply multiply the two denominators. So I can multiply the first term by 7 over 7, and I can multiply the second term by 9 over 9, right? Because 9 times 7 is 63. This will give me a common denominator of 63. Okay. Now, 7 times 9 is 63. 7 times 5 is 35. 2 times 9 is 18. And 7 times 9 is 63. So we have converted both sets of terms here to give me a common denominator of 63. Now I can just add the numerator here. 35 plus 18. Okay. 35 plus 18, let's see, that's going to give you 3, is that 53? 53 over 63 is going to be our answer. Can we reduce that? I don't believe we can. I don't believe we can reduce 53 over 63. So, we're done. That's it. Let's go to number 4. Okay. Let's do a different color to distinguish. Here I have 4/8 minus 1/4. My least common multiple for this one's pretty easy to see because we can make that 4 into that 8 really simple. So my common denominator here should be an 8. So I want a denominator of 8 for both. Here, this one doesn't change at all. Here, I need to multiply by 2 over 2 in order to make this denominator 8. 4 times 2 is 8. 1 times 2 is 2. Now I can do this simple subtraction. Here I have 4 minus 2 is 2. I'm left with 2 8s. Wait a minute, 2 8s reduces. How do we reduce 2 8s? Well, I need to divide the numerator by 2 and the denominator by 2 and reduce by a factor of 2, which would leave me with an answer of 1/4. Remember, if you can reduce, reduce. Always reduce to lowest terms. Alright, take me a little sip of water here. Alright. Number 5 says 3/9 plus 1/3. Now, I'm going to show you something else you can try as you become more advanced and as you begin to notice things. Okay? Now, if I'm looking at 3/9 and 1/3, I could convert the denominator of both to 9 because that would be the least common multiple. But as we progress through mathematics, we need to start noticing things. And one of the things I notice is that 3/9 should reduce to 1/3 if I had it in simplest terms. And if I did that, I would have a common denominator of 3, and I wouldn't have a reduction step in the last step. So, instead of multiplying to get a least common multiple, I could just put my first term in simplest terms to start with. And then I just have 1/3 plus 1/3, which gives us a common denominator of 3, and I can add the numerator, and it's now in lowest terms of 2/3. So like I said, it's a little more of an advanced catch right there. But that's where we're trying to get you, right? We're trying to show you all of these small steps and bring you up to a level where you don't always have to do things the hardest way. You can notice something real quick like that, pick it out and say, hey, if I reduce this is actually going to be an even easier addition than if I were have to multiply everything up and then do an additional reduction step. We want you to get and make those little connections. If you don't, it's okay. You could have multiplied the second term by 3 over 3. You would have gotten 3/9. Again, you would have done 3 plus 3 is 6. You would have wound up with 6/9. And then you could have reduced that to 2/3. That method would work as well. A lot of times, there are several different avenues to get to the correct answer in mathematics. I just wanted to show you a different one. Okay, here we have 2/5 plus 1/10. Now, everything's in reduced terms, so we can't do a little quick step here. But it is pretty easy to see that our common denominator here should be a 10, which means I need to multiply this by 2 over 2. So this is going to be 4 over 10 plus 1 over 10. 4 plus 1 is 5. Here I have 5/10, which can easily be reduced because 5 can go into both of them. And 5/10 should reduce to 1/2. Very nice. Very, very nice. Okay. Let's see what else I can do here. Okay. Now let's add 4/5 plus 9/10. Once again here, I'm going to multiply this term here by 2 over 2 so that I can have a common denominator of 10. This should give me 8/10 plus 9/10. 8/10 plus 9/10 should give me 17/10. And like I said, I'm going to leave it just like that. I'm good to go. 4/6 minus 1/3. Hopefully you can see the least common multiple is 6 here. So I need to turn this into a 6. The easiest way to do that is multiply by 2. So I'm looking at 4/6 minus 2/6. 4 minus 2 is 2. This reduces to 2/6, which you should be able to further reduce here to 1/3. Alright, let's look at number 9. Number 9 says 3/12 plus 2/4. Uh-oh. Do you see it? Take a minute. Do you see it? Look at number 5. Do you see it again? What can we reduce this first term by? We could actually reduce both terms, but let's just reduce this first term and see what happens. Could reduce this first term by a factor of 3, because 3 goes into 3 and 3 goes into 12. This is going to reduce this to 1/4 plus 2/4. It wouldn't do me any good to reduce this second term because then I'd have a completely different denominator. Right now I have a matching denominator of fourths because I just did a reduction step. Okay, 1 plus 2 is 3. This gives us 3/4 because we used our little sneaky little trick right there. You don't always have to multiply up. Sometimes you can reduce down and they'll match. Alright, got a few more. Got about 6 more. Let's look at 5/12 minus 1/6. Common denominator here should be a 12. So I'm going to multiply this by 2 over 2. So I'm looking at 5/12 minus 2/12, which should give us 3/12, which we should be able to reduce by a factor of 3 to 1/4. Okay. Here I have 2/8 plus 3/9. Oof. Now, I'm actually going to do this one 2 ways. That's exactly what I'm going to do. I'm going to do this one 2 ways. Okay. I'm going to do the first way on top. Now, the first way would tell you that, okay, I need a least common multiple here. Okay, if I need a least common multiple here, then I need 8 times 9 will probably give me like a 72 as a denominator, right? That means I have to multiply this one times 9 over 9 and this one times 8 over 8, right? 9 times 2 is 18. 3 times 8 is 24. 18 plus 24 is going to give us, so that'd be a 2 there, 1 up top, 42 over 72, which we're then going to have to reduce, right? So what reduction factor can we reduce this by? Let's see. What goes into both of those? Okay. I know 2 goes into both of them. I think 6 goes into both as well. Let's try 6. How many times does 6 go into 42? 6 goes into 42 8 times. Nope. Oh, if you did your math multiplication sheet, you should be screaming at me right now, right? You should be screaming at me, saying, Mr. Shipes, you're wrong. You're wrong, Mr. Shipes. 6 times what's 42? 7. All right. If I divide 72 by 6, that should give me, what, 12? So this should reduce it to 7/12. That should be our answer. Now you're like, okay, Mr. Shipes, what was the other way that you were thinking of? Well, I'm going to show you the other way. In the other way, I would have reduced both terms, which means that instead of doing this first common denominator, I would have reduced this first term by dividing by 2, which would have reduced this to a 1/4. I would have reduced this second term by a factor of 3, which would have given us a 1/3. Okay, now I still don't have a common denominator here, but the common denominator from a 4 to a 3 should give me a 12, right? So this should convert to a common denominator of 12, which means I need to multiply this first term by 3/3, and this second term I need to multiply it by 4/4. 3 times 1 is 3, 4 times 1 is 4, 3 plus 4 is 7, and now we have 7/12. More than one way to get there, ladies and gentlemen. More than one way to get there. Completely up to you, but make sure you do your multiplication right, because Mr. Shipes will catch you. And sometimes I throw some in there just to see if you'll highlight it, or just to see if you're just drearily following along, not paying attention. Alright, number 12, we have 1/4 minus 1/8. Common denominator here should be an 8, which means I need to multiply this one by 2/2. 2 times 1 is 2, 4 times 2 is 8. 2/8 minus 1/8 is 1/8. Whoop-de-doo. Number 13, I've got 6/7 plus 2/6. Alright, you got some options on this one. 7 times 6 is what? Oh, you just did that. 7 times 6 is what? 42. Okay. So, if I make 42 my common denominator, then I'm multiplying this one by 6/6 and this one by 7/7. It's going to give me a common denominator of 42. 6 times 6 is 36. 7 times 2 is 14. Now I'm looking at 36 plus 14, which is going to give me a 50. So I have 50/42, which does obviously reduce if you divided both of those by 2. 50 divided by 2 is 25. 42 divided by 2 is 21. And I think that's as simple as it goes right there. Okay. You could have reduced that second term as well to 1/3, and then you would have had a common denominator of the 21, and it would have come out pretty nice too. You could try that on your own if you want to. Use the other little trick we've been using here and there. It would have worked as well. Might have been quicker. Who knows? Try it and see. Here we need to do 1/3 minus 1/7. Common denominator there is going to be 21, because I'm going to multiply this one by 7/7. I'm going to multiply this one by 3/3. This is going to give me 7/21 minus 3/21, which should give me 4/21 as my answer. Alright, last one. 7/8 plus 4/5. Okay. Now, common denominator here, I'm going to go with 40. Multiply this one by 5/5, and this one by 8/8. This always works, by the way. So you can always multiply the opposite fraction by the denominator of the other fraction, and you will find a common denominator that way. Like I said, the simplification might be a little more advanced and take a few extra steps, but it does always work. 7 times 5 is 35. 4 times 8 is 32. 35 plus 32 is going to give us a 67/40, and I do not believe that that reduces. So we have reviewed addition and subtraction of fractions in both common denominator terms and in having to find a common denominator. Let's move on to adding and subtracting decimals. Fun times. Now, the importance to me of being able to add and subtract decimals is the most common used decimals in our world, and especially in our country, is dollars and cents. So if you look at the very first one here, you can think of that as $800.54 plus $90.52. And you could say, oh, I've got a calculator on my phone and I'll always have that. I even have a calculator on my watch. I'll always have that. Or I'll have we'll always have access to calculators. That's all well and good, right? But it's always good as well to not have to use it, okay? If you're running a retail business, or if you're working at a retail business and you're having to do cash and change back and forth, you shouldn't always rely on the computer that's sitting in front of you. Okay, depending on where you work, you might have to work at an old feed and seed store or old hardware store, something like that, and you might not be able, or their system might not be automatic. You might have to either pull your phone up and do it or whatever, but hopefully you can handle some of the basic dollars and cents, right? So if something's 75 cents and I give you $1, you should be pretty automatic in saying, hey, here's 25 cents back. You shouldn't have to put that in on a calculator, right? That's why it's really important to have at least a basic knowledge of adding and subtracting decimals. If something costs $1.25 and then something else costs 60 cents, and you're buying both of them, we won't even talk about tax right now, but if you're buying both of them, $1.25 plus 60 cents is going to give you $1.85 worth of stuff that you're buying. You should be able to do that in your head, right? So, I mean, if you've got $1, something costs 60 cents, you should know that you're getting 40 cents back. That should be automatic. You shouldn't have to pull your calculator out and do that. That needs to be in your brain. You need to be able to work with these in your brain, especially with some of the smaller, easier ones, right? Dollars and cents, they add up, my friend. Got to be able to do them. Okay? So let's look at some of these. Let's do some of these by hand. You can cop out and do them on the calculator all you want to. You can check yourself on the calculator. I encourage anybody that's taking a test to check them on the calculator because it's easy to make a little mistake. It's better to be safe than sorry, especially if you're testing or quizzing or anything like that. But in a basic sense, you should be able to get most of these pretty close to right in your head if you're doing them, right? Now, I'm not saying the ones we got on the worksheet here. I'm just talking about in general, if you're messing with dollars, buying something from the store, buying something from the farmer's market, per se, you should be able to work with something. All right, let's see what we got here. Now, if you're doing some of these more complicated ones by hand, the first thing you got to do is know how to set it up. Okay, if I'm setting this up, I have 800.54 plus 90.52. When you're adding and subtracting decimals, you have to line the decimals up. Okay, that's your most important thing here. Don't line the numbers up, line the decimals up, and then the numbers will follow. Okay, and you'll see what I mean here on one of the next couple. Okay, first one's pretty straightforward. And then we just add. That's all we're doing here. We're adding. 4 plus 2 is 6. 5 plus 5 is 10. Carry the 1. The 0 is there and a 1. I'm going to drop my decimal. Okay, straight on down. 9 and 0 is 9. So we're looking at $891.06 right there. We was able to add it up by hand. Nothing to it. Remember, adding and subtracting these decimals, you gotta line the decimal up. Okay. Look at this one over here. I've got $343.40 plus 5.607. Okay. If I'm adding these two here, I'm going to write the first one down. And then I'm going to write the second one down where I am lining these decimals up. Okay. Now, to me, I can add these without having to add 0 placeholders in the numerator. But if it makes you feel better, you can put some 0 placeholders in the numerator to help you add. It'll definitely help you subtract if you do that. Addition is pretty straightforward though, but add the zeros if it helps. Alright, 7 plus 0 is 7. 0 and 0 is 0. 6 and 4 is 10. So I need to carry that 1. I need to drop that decimal. 5 plus 3 plus 1 is 9. I got a 4 and a 3 there. So I've got 349.007. So we've knocked out some addition. Let's look at subtraction. Okay. Let's change it up with my color here so we don't get anything mixed up. Alright, so I've got 94.9 minus 41.871. Alright, here's the dealio here. Alright, line the decimals up. So you got these extra terms over here. When you're subtracting, it is pretty smart here to put the zeros. Reason being is, remember, it has to be big enough on top in order to subtract from it on the bottom. Here I can't subtract 1 from 0, so I need to borrow. Okay, so I'm going to borrow from this 9. It's going to turn into an 8, which is going to turn this into a 10. But then I need to borrow from that, make that a 9, and then turn this into a 10. Okay, so that here I get 10 minus 1, and some people cross those out too. Whatever method you were taught for this borrowing is fine. I'm not going to knock you either way. I was taught none of these methods that I'm showing you. I was taught a mental method, so it's kind of hard to show you a mental method, but I might talk you through it in one of the more advanced ones down here. But I'm doing 10 minus 1 is 9. 9 minus 7 is 2. 8 minus 8 is 0. Drop my decimal. 4 minus 1 is 3. 9 minus 4 is 5. So my answer is 53.029. Let's try this one. I've got 809.144 minus 15.96. Like I said, you can put a placeholder 0 there if it makes you feel better. That's fine. Okay. 4 minus 0 is 4. I can't do 4 minus 6 because 4 is too small, so I do need to borrow here. I can do that. This is going to turn that into a 14. Okay, 14 minus 6 is going to give us, 14 minus 6 is going to give us 8. I can't subtract 0 and 9 here because 0 is too small. I need to borrow from this 9. I'm going to make that an 8. I'm going to turn that 0 into a 10. 10 minus 9 is 1. I'm going to drop my decimal. 8 minus 5 is 3. I can't subtract this 0 and 1 here, so I have to borrow from the 8. Make this a 10. 10 minus 1 is 9. So I'm looking at 793.184. 793.184. Not too bad. Not too bad. Don't be intimidated. And there are a lot of them on here. But we're going to go through them. Okay. Here to help. Here to review. A lot of people get stuck on these. So let's keep going. Alright. We have 803.309 minus 133.36. So I'm looking at 803.309, 133.36. So you can put the 0 holder there, that way everything lines up. 9 minus 0 is 9. I cannot subtract this here, so I need to change that to a 2, this to a 10. 10 minus 6 is 4. Need to borrow from this 3 here, change that to a 2. 12 minus 3 is 9. Bring down my decimal. I can't even borrow from the 0, so I have to go all the way over here. Make this a 9, make this a 12. Because I'm going to borrow from that and make that. So 12 minus 3 is 9. 9 minus 3 is 6. 7 minus 1 is 6. I'm looking at 669.949. Easy enough. Alright. We've got 767.3. 767.3 minus 24.9. Okay. I can't subtract the 3 and the 9 here. 3 is too small. I need to borrow. So it's going to change that to a 13. 13 minus 9 is going to give me a 4 here. 6 minus 4 is 2. 6 minus 2 is 4. And then I've got my 7. So I'm looking at 742.4. Okay. Let's do the next one. Let's do orange. Alright, I've got 489.08 minus 4.2. Okay. Gotta put a 0 placeholder here so everything kind of lines up. 8 minus 0 is 8. Here I have to borrow from the 9. I'll make that an 8, and I'll make this a 10. So this will make this an 8. 8 minus 4 is 4. 8, 4. I'm looking at 484.88. Alright, now back onto addition. Back onto addition. So here I'm going to do 921.74 plus 2.7. Remember, line those decimals up. You can put the 0 placeholder if you want to. Here I'm looking at a 4. 7 plus 7 is 14. Need to carry the 1. 2 plus 1 is 4. Don't forget to bring down that decimal. And then 2 and 9. So I'm looking at 924.44. Simple enough. Let's do a few more. Then I'm going to leave it up to you on some of them. Okay, let's add this one. 384.94, 17.348. And this is an addition. Okay, I can put the 0 placeholder if I want to. 8 plus 0 is 0. Or sorry, 8 plus 0 isn't 0, is it? 8 plus 0 is 8. 4 plus 4 is 8. 9 plus 3 is 12. Carry the 1. Don't forget to drop your decimal. 7 plus 4 is 11. Plus 1 is 12. Carry your 1. 8 plus 1 is 10. 3 plus 1 is 4. So I'm looking at 402.288. All right. Now I'm going to do 260.65 minus 40.9. Okay, going to put a 0 placeholder here. Don't forget to line your decimals up. 5 minus 0 is 5. Here I can't subtract 6 from 9 because 6 is too small. So I need to go over and borrow, and the first one that I can borrow from is this 6. Okay, that would change that to 10, but remember you do have to borrow from it, so it technically changes it to a 9, and this changes to a 16. 16 minus 9 is going to give you a 7. 9 minus 0 is going to give you a 9. 5 minus 4 is going to give you a 1, and then 2 minus nothing is going to give you a 2. So I'm looking at 219.75. Now, I've gotten probably half-ish way through this worksheet. I'm going to leave the other half to you. And here's the deal. Okay, just line your decimals up, add and subtract as necessary. Try it by hand. And then what I want you to do is I want you to pull out a calculator. It could be a very basic one. It could be the basic one on your phone. And practice typing them in to check yourself. Now, I do have the answer solutions obviously attached to the end of the page, so you can check yourself that way. But on top of getting used to doing it by hand, practicing typing the stuff in on the calculator is actually going to be helpful, as much as I hate to say that. It's actually going to be helpful for you going forward as well. Because getting used to where the buttons are on the calculator, even the addition and subtraction and the decimal buttons, is going to be helpful going forward, because you will do a lot of addition and subtraction of decimals as you move forward in mathematics, right? So make sure you can do it by hand, but also make sure you're well at typing it on the calculator, and make sure the two line up. Make sure the two line up. So like I said, you can use your basic calculator on your phone. You can pull out the TI-84, which is the one we use at USC Aiken a lot. But you can pull out that. Do it by hand first on the rest of these. Then pull out your calculator, check it on your calculator, and then check both with the answer solutions. Okay? Get efficient, right? Obviously, really, really good to be able to do some of these decimals by hand, because a lot of these on this worksheet are fairly large, because I wanted you to have a challenging practice. But in real life, you know, you messing with dollars and cents, anything under 20 bucks, hopefully you can do mentally in your head to a point to know about what change you should receive when you're at whatever establishment buying what you need. Heck, even adding the tip on a bill at a restaurant, right? If you're trying to make it an even 40 bucks and the meal was $38.25, right? And you're trying to leave a really crappy tip and you're just wanting to make it an even 40 bucks. I mean, you got to know that all you're going to add is $1.75, which is, like I said, a really, really bad tip. So don't be a poor tipper. Anyways, I will see y'all next lecture. If you have any trouble with this, let me know. We can go over some additional stuff with it. But like I said, practice it by hand, then go and practice it on your calculator. Both will be efficient. Need to know how to do both. And need to get familiar with whatever calculator you plan on using going forward. We use the TI-84 at USC Aiken for a lot of our classes. So I suggest that one if you're planning to come to our college. Go ahead and get that one and practice some of these keystrokes on it so you can get familiar with using it. So I'll see y'all next time and look forward to continue working with you.